A warm welcome to one and all. Myself, C. Bhuvan Chaudhary, currently pursuing integrated M.Tech software engineering in VIT Vellore. Today I am going to explain about binary tree data structure. Now let's see what is a binary tree. A binary tree is a tree data structure in which each parent node can have at most 2 children. Each node of binary tree consists of 3 items: data item, address of left child, address of right child. A binary tree looks like this. 1 is parent node and 2 is left child of 1, 3 is right child of 1 and 4 is left child of 2, 5 is right child of 2, 6 is left child of 3, 7 is right child of 3. Again 4 consists 2 childs, 5 has 2 childs, 6 has only right child, here left child is not present, 7 has only left child, right child is not present. Now let's see properties of binary tree. Let us consider this binary tree. This is 0 level, first level, second level. Maximum nodes at level L equals to 2 power L. This is 0 level. At 0 level only parent node exists. At first level there can be at most 2 nodes. At second level there can be at most 4 nodes. So we can find maximum nodes at level L by finding 2 power L. Maximum nodes in a tree of height h is 2 power h minus 1. Let us consider this binary tree. This binary tree consists 3 levels: 0 level, 1 level, 2 level. The number of levels indicates the height of the tree. So we can find maximum nodes in a tree of height h is 2 power h minus 1, that is 2 cube minus 1 in this case. So 8 minus 1 gives us 7. 1, 2, 3, 4, 5, 6, 7. Now let's see structure of a binary tree. It consists data item and address of left child and address of right child. A node of binary tree is represented by a structure containing data part and 2 pointers to other structures of same type. So we are declaring structure node which consists data of integer type and left pointer and right pointer. Left pointer points to the left child and right pointer points to the right child. So we are declaring structure node pointer left and struct node pointer right. Node consists of data and left pointer and right pointer. Left pointer points to the left child, right pointer points to the right child, and again node consists of left pointer and right pointer, and next node consists of data and then left pointer and right pointer. Now let's see how to build a binary tree. First we should include the header files, and we are creating a structure node which consists item of integer data type and struct node asterisk left pointer and struct node up to right child pointer, and we are creating a function to create a new node which receives a parameter value. We are creating new node by using malloc function. We are assigning value to the new node item, and initially we are initializing the left child and right child with null, and we finally return the new node. And next struct node asterisk insert left is used to insert on the left of the node. It will receive 2 parameters, one root pointer and value. We are assigning root left. Create node will create the node and assign value to the root left, and finally we are returning root left. Struct node pointer insert right will insert the value to the right of the node. It receives 2 parameters, struct node root and value. It assigns the value to the root right. Create node will create the new node and assign to the root right, and finally return the root right pointer. Now we are creating a simple binary tree. From the main function we are declaring the root pointer and creating a parent node with 1. And next we will insert left. We are sending 2 parameter root and value. We will create second node. And next we will insert right. Will create 3. Insert left will assign to left of 2 4. Insert right will insert right of 2 5. Insert and next insert left and insert 6 and insert right will insert at 3 right 7. Finally we are printing the total binary tree. Now we have printed the binary tree 1 2 3 4 5 6 7. Now let's see about binary tree traversals. Pre-order traversal, in-order traversal, post-order traversals. First we will go to pre-order traversal. In pre-order traversal we travel to root and next left subtree and next right subtree. Let's see how. First we go to the root item and add it to the pre-order sequence 1 and next check the left subtree of 1. If it exists we should travel to next 2. We should add 2 to the pre-order sequence and again check the left subtree of 2. 4 exists, so 4 we should add 4 to the pre-order sequence and again check the left subtree and fourth subtree, both are absent, so we should come back to the root item. And next we should go to the right subtree. Exists, so we should add 5 to the pre-order sequence and check the both left subtree and come back to the 2 and come back to the root item. And next we should go to the right subtree. We should check the left subtree, that is 6 is the left subtree, so we should add 6 to the pre-order sequence and check the both left subtree and right subtree, both doesn't exist, so we should come back to the root item and check the right subtree. 7 is the right subtree of 3, so we should add to pre-order sequence and check the left subtree and right subtree, both doesn't exist, so we should come back to the root item. We have traversed to left subtree and right subtree, so we come back to the root item. Now we traverse the whole binary tree. Function for implementation of pre-order traversal. Function with return type void pre-order traversal. It receives an argument parameter root which points to the node. First we will travel to the root item and next to the left subtree and next we should call function for right subtree. It is a recursive function, so we are adding condition to break recursive function. So if whenever root is null, it will return. Now let's code it. First we should include header files and create the structure node. We have a function to create the new node and we have function to insert left child and next function is to insert at right child. Pre-order traversal function, it will receive a single parameter root which points to the node. First we travel to the root item and next we travel to the left subtree and next we travel to the right subtree. Since it is a recursive function, we should add a break. Whenever root is null, it will return. Now in this program we will build a simple tree. From the main function we declared a root which will create first root of parent node 1 and whole tree, and next we will find the pre-order traversal for the about binary tree. Let's run it. Now we got pre-order traversal 1 2 4 5 3 6 7 is the pre-order traversal for this binary tree. Now let's see about in-order traversal. In in-order traversal, first we travel to the left subtree and next we travel to the root item and next we travel to the right subtree. Let's see how it works. First we go to the root item and next we check the left subtree, that is 2. We go to 2 and check the left subtree, so left subtree exists, so we go to 4 and add 4 to the in-order sequence. Since it doesn't have left subtree and right subtree. We add it to the in order sequence and come back to the root and add root item to the in order sequence and check the right subtree of 2 exists. So we should add 5 to the in order sequence since it does not exist left subtree and right subtree. So we add 5 to the in order sequence and come back to the previous node 2, that is, and come back to 1 and add 1 to the in order sequence. Since next we go to the right subtree of 1, that is 3, and check the left subtree of 3, that is 6. 6 doesn't have left subtree and right subtree, so we should add 6 to the in order sequence. And next come back to the previous node, that is, and add it to the in order sequence and left subtree. So 7 does not have left subtree and right subtree, so we should add 7 to the in order sequence and come back to the root item and finally come back. Since we have traveled whole binary tree, the in order sequence of the binary tree is 4251637. Function for implementation of in order traversal. It is a return void type in order traversal. It receives a parameter of data type structure node pointer, that is root. In order traversal, first we travel to the left subtree and next we travel to the root item and next we travel to the right subtree. Since it is a recursive function, we are adding a recursive break. Whenever root is null, we will return. Now let's code it. First we should include the header phase and next create the structure node, and we have function to create a new node, and insert left will create the node at left child and insert right will create at the right. Now let's see the function for in order traverser. In order traverser function receives a single parameter, that is struct node pointer, that is root item root. In order traverser, first we travel to the left subtree and next we travel to the root item and next we travel to the right subtree. Since it is a recursive function, we are adding a recursive break. Whenever root is null, we will return. In this program, we will build a small tree and find the in order traversal. From the main function, we are creating a small binary tree and finally printing the in order traversal for the binary tree. Now let's run it. Now we can see 4251637 is the in order traversal for this tree. Now let's see about the post order traversal. In post order traversal, first we travel to the left subtree and next we go to the right subtree and finally to the root. Now let's see how it works. First we go to the parent node and check the left subtree, it exists, so we go to 2, and check the left subtree of 2, it exists, so we go to 4. 4 doesn't have left subtree or right subtree, so we add 4 to the post order sequence and we come back to the previous node, that is 2. Since 2 has right subtree, so we go to 5. 5 doesn't have left subtree or right subtree, so we should add 5 to the post order sequence and we come back to the previous node and add root item to the post order sequence and come back to the root item, and next it has right subtree, so we go to 3. 3 has left subtree, so we go to 6 and add 6 to the post order sequence since that does not have left subtree and right subtree. Go back to the root item and check the right subtree. 7 is the right subtree of 3 and 7 does not have left subtree and right subtree, so we should have 7 to the post order sequence and next come back to the root item and next add it to the post order sequence and come back to the previous node, that is 1, and add it to the post order sequence. Now let's function for implementation of post order traversal. Function is void return type. It receives a single parameter root pointer which points to the node. In post order traversal, first we traverse through left subtree and next we travel to right subtree and finally to root item. Since it is a recursive function, we should add a recursive break. Whenever root is null, we will return. Now let's code it. First we should include the header files and create the structure node we have create node function which will create a new node, and insert left function will insert the node of the left, insert right on the insert right of the node, and we have a function for the post order traverser which will receive a single parameter node which points to the node post order traversal. In first we travel to the left subtree, and next we travel to the right subtree, and next finally we travel to the root item. Since it is a recursive function, we should add recursive break. Whenever root is null, we should return from the function. In this program, we are creating a simple binary tree. From the main function, we are creating the binary tree and printing the post order traversal for the binary tree. Now let's run it. Post order traversal 4526731 is the post order traversal for this binary tree. Thank you for watching this video. From this video we have learned lot about binary tree.